What is initial population and the relative rate of growth as a percentage of this bacterium population? The initial bacterium in a culture is 500. A sample count of bacteria in the culture and finds that the relative rate of growth is 40% per hour. We use the exponential growth model with is equal to 500 and R is equal to 0.45. To get the function 500 is elevated to the power 0.45 t, where t is measured in years.
I'm going to solve the question C, that it says, after how many hours will the number of bacteria reach 10,000? First of all, we need to find in after how many hours the number of bacteria reach in 10,000. First, we have the bacteria, but we don't know in how many hours it will reach the amount of 10,000. And then we have 500. 500 that is multiplying E goes to the other side of dividing, like this one. This is the bacteria that we want to know in how many hours we need. We pass 500 dividing in the other side, and the equal is E, and then the result, we simplify, we divided 10,000 we divide 10,000 over 500, and the result will be 20 equal E, and that's the result.
Then we apply the logarithmic function to 20 and it cancels E, like this. That is beside the logarithmic, and this gives us as a result to 2.995 equal to 0.45 t. T is multiplying to 0.45. So this passes dividing to the other side, and it gives the result of 2.999 between 0.45 equal to t. And this simplifies, it gives us a result of equal to t equal to 6.7.
Hi, I am going to solve the question B. Is how many bacteria are in culture after 3 hours? Here we have the equation that is n t 500 e elevated to the power 0.45 t. 0.45 multiplies by 3. Here we multiply 0.45 times 3, and there are the hours that we are searching for. So then we got 500 e elevated to 1.35. multiply E, that is a specific number, and you elevate it to 1.3, and this gives us a result of equal 3.857, and this gives us this result, and then 500, you multiply that by this number, 3.857, and this gives us the result, that is after 3 hours, this is going to be the culture of bacteria. This will be the result of our question B.
This graph shows that the function 500e elevated to the power 0.45t. We have the initial population that is 500. When we graph, we determined that this line continues growing upward. And this makes a reference that the amount of bacteria will continue
We get to the
growing.
conclusion
That the bacteria will increase when the time passes and they will reach a high amount of bacteria.
We also conclude that in our graph it will go upward and it will continue growing. Also, the amount of bacteria will increase. Thanks.